So we're moving on today and we're continuing our unit on inequalities. We're going to look today at compound inequalities, and these compound inequalities use words that join inequalities together. So we'll have and as a word that would join an inequality, and that's called a conjunction. It says a sentence formed by joining two sentences with and, such as x is greater than or equal to 3 and x is less than or equal to 7, can be written as 3 is less than or equal to x, which is less than or equal to 7. The graph is below. We'll look at it in a moment. That's called a conjunction when you have two inequalities joined by and. A disjunction is a sentence formed by joining two sentences with or. An example, x is less than -2 or x is greater than or equal to 1. That graph is also below. Let's look at the box. Essential understanding. You find the solutions of a compound inequality by either by identifying whether the solution sets of the distinct inequalities overlap or by combining the solution sets to form a larger solution set. On the left side, the graph of a compound inequality with the word and contains the overlap of graphs of two inequalities that form the compound inequality. So when they graphed x is greater than or equal to 3, they had a closed circle on 3 and they graphed everything to the right. When they graphed x is less than or equal to 7, they had a closed circle on 7 and they graphed everything to the left. That was smaller. Then you'll notice that these are the boundaries. So we're looking where those two inequalities overlap. Well, where do they overlap? At x equals 3 and x equals 7. So everything in between is what is graphed when you have a conjunction or an and inequality. When we look at an or, the graph of a compound inequality with the word or contains each graph of the two inequalities that form the compound inequality. For example, x is less than -2. We have an open circle on -2, and we're graphing everything to the left. When we look at x is greater than or equal to 1, we have a closed circle, and we're graphing everything to the right. Well, how does that look when it's put together? It is a larger solution set. It's basically one number line with both inequalities graphed. And you'll notice that they graph away from each other. It's the solutions that graph away from each other. So it looks like that. Okay, so let's get started. And let's go ahead and do some of these. It looks like some of my problems didn't come through again. Hopefully they did on your review sheet, but I'll write them in as we go on. Okay, so let's look. We have in problem 1, writing a compound inequality. What compound inequality represents the phrase? Graph the solutions. All real numbers are greater than -2 and less than 6. This tells us that this is a conjunction because it has and. So it says it's greater than -2 and it's less than -6. That really means this. It means that -2 is less than x, which is less than 6. It makes a compound inequality. And when we graph that, what does that look like? Well, let's start with -2. We'll go to 0, 2, 4, 6. I'm going just by 2's. I have an open circle on -2. and an open circle on 6. So it's everything greater than -2, but it's also everything less than -6. So it is where they overlap, and that's where the two would overlap. B, all real numbers that are less than 0 or greater than or equal to 5. So x is less than 0 or x is greater than or equal to 5. What is this going to look like when we graph it? These are going to graph away from each other. So we have 0, 1, 2, 3, 4, 5, 6. Greater than or equal to 5 is a closed circle on 5, and it graphs to the right. Less than 0 is a closed circle, and it graphs to the left. All right, let's look at these examples. I'm sorry, I guess this was also done in an older version. So we'll go ahead and just fill them in as we go. Number 1, it says examples, graph each compound inequality. I have here x is greater than 2 and x is less than 5. When I go to graph this, I don't have to solve anything yet. So when I go to do this, I'm going to go by ones on my number line. And I'm going to see greater than 2, that's an open circle going this way. And less than 5, that's a open circle but going to the left. The other was going to the right. So again, the solution is everything in between them. Number 2, x is less than 7 or x is greater than 10. I'm going to have you do that one on your own in a few minutes, but I want you to have the problem. Number 3, solve and graph each of the following. -4 is less than x minus 5, which is less than -1. So I know this is a conjunction, and because x is in between the two inequalities. I want to get x by itself by adding 5. Where do I add it? To itself, to -1, and to -4. And -4 plus 5 is 1, is less than x. We got rid of that 5, which is less than 4. When I go to graph on a number line, I will, my number line got slow, start at 1. No, 0. 1, 2, 3, 4, 5, 6, 7, 8. Open circle on 1. Open circle on 4. It means 1 is less than x, means everything greater than 1 that goes all the way to 4, and less than 4 means everything that is smaller than 4 that goes to 1. Okay, let's go and write number 4. Number 4, we have 4w plus 3 is less than -5. The or was written there. -2w plus 7 is less than 1. And I'm going to give you an opportunity to do that one. Number 5 says today's temperature will be higher than 32 degrees, but lower than 40 degrees. Okay, so higher than 32 degrees, but lower than 40 degrees. This tells me that this is going to be a compound inequality, which is a conjunction or an and statement. So lower than 40 means less than, but higher than 30. Remember, if the 32 goes on this side, that means x is greater than 32 degrees. So we're ready to graph this. I'm going to go start at 30 and go by 2s. Open circle on 32 because it's higher than 32. Open circle on 40. So any of the temperatures in between there will make that true. Okay, it looks like these problems didn't come through either. So let me write those out. It should be in number 1, x is less than or equal to 1, or x is greater than 3. So it says in problems 1 and 2, graph. And then 3, 4, and 5 solve and then graph. So this is just like we had been doing on the front page. Less than or equal to 1 and greater than 3 or greater than 3. So less than or equal to means a solid circle, and we'll have all solutions including the one that are smaller. Greater than 3 is an open circle. It doesn't include 3, but it's everything greater than that. Number 2, you'll work this on your own, and this is x is greater than or equal to -2, and x is less than 0. So the and symbol is, and word is written out, but what does that really mean? It means that -2 is less than x, which is less than 0. So if you like to write it that way, that's fine. Number 3, we're going to solve this in terms of t first, and then we will graph it. 2 is less than t minus 3, which is less than 5. We're going to get t by itself by adding 3 to itself, to 5 into 2. 2 plus 3 is 5, is less than t. The 3 is gone, which is less than 8. When I go to graph this, it's an and, so I know that my solution is going to be everything in between there. 1, 2, 3, 4, 5, 6, 7, 8. Open on 5, everything larger. Open on 8, everything smaller, so it's graphing everything in between. You'll do number 4 on your own, and that one is negative 4v minus 3 is less than 5, or negative 2v minus 7 is greater than 1. Number 5 we'll do together. 4v plus 3 is greater than negative 5. The and is written out again. Negative 2v plus 7 is greater than or equal to 1. I'm going to solve the left one in terms of v by adding 3. I get 4v is greater than, not by adding 3, by subtracting 3. Negative 8. Divide by 4. V is greater than negative 2. And now I'm going to subtract 7 on this side. Negative 2v is greater than or equal to negative 6. Ooh, this time I'm dividing by a negative, so I have to switch that inequality and make that v is less than or equal to 3. What does this mean? And as a compound, it means that negative 2 is less than v, which is less than or equal to 3. We're ready to draw. And when we do, we have negative 2, negative 1, 0, 1, 2, 3, 4, 5. Open circle on negative 2, close circle on positive 3. This did this earlier. Sorry about that. Open circle on negative 2, close circle on 3, and then we're going to shade everything in between. Okay, so I want you to go back and try these that we didn't do together and see what you get. And when we come back on, I will give you the answers to those so you have them. And then we'll do part 2, which is going to be looking at absolute value equations and inequalities.